We're in the UK's first passive house renovation. This is a Victorian terrace built in the 1860s, 1870s, and we have spent the last 9 months turning it into a super efficient, low energy house.
What does a passive house retrofit mean? Now, passive house is a German standard that's been developed over the past 20 years. What it relates to is a house that has very, very low energy consumption, but also is a comfortable, pleasant environment to live in. And it comes down to a few kind of key areas, but also to a whole design philosophy.
There are 7 million solid wall homes in the UK, and the building industry is wondering how on earth we are going to renovate them to a low energy standard. This project is an extreme example, just showing one way of doing that.
What we're really trying to do here is to keep the architectural heritage of Britain and of London especially alive in this conservation area, while still moving on to a low energy lifestyle. And what this is about keeping the structure of the building, but changing the skin and all the services inside. It's a full renovation.
And hopefully through doing the project we will have learned a number of techniques and familiarised ourselves with a number of technologies that will be useful when tackling the rest of the homes around the country.
The first step to building a passive house is to reduce the energy consumption, reduce the heat loss of the house as far as possible. So it starts with 130 millimeters of Kingspan phenolic foam insulation. On the inside of that there's an airtight layer, and this airtight layer is made of chipboard, OSB chipboard, which is taped at all the joints, and that runs continuously throughout the whole exterior envelope of the house. On the inside of that there's another 50 millimeter layer of the same phenolic foam, and on the inside of that we put our plasterboard. Now that seems like a lot of space to lose. It's not that much. We've insulated the front and rear walls of the house. We've put much less insulation on the side walls because your neighbour hopefully will heat their house as well. On top of that, we've taken out all the chimney breasts, which used to run the whole way through the house. Great big double chimney breasts on both sides, so we've saved a lot of space doing that. So once you have the insulation on the inside of the walls running the whole way through the house, then you have to look at cutting off what are called thermal bridges. And most insulation has breaks in the insulation. It has areas where the insulation is not continuous, where, for example, a floor joist or a piece of brickwork runs through the insulation, and there's a lot of heat loss at those junctions. There's also a lot of condensation at those junctions, and so you get problems with damp and moisture inside the house. One of the main techniques we've used is actually to stop the thermal bridges that are due to the floor joists, which usually sit in pockets or in joist hangers on the external walls. So to avoid that, we've rehung each of the floors on a steel beam running transversely, perpendicular to the joists, to the wood. And those steel beams sit in insulated pockets in the side walls, in the party walls. And so at a stroke you've avoided all these great big problems of the thermal bridging, of the condensation, and of the airtightness loss. In the very coldest parts of the winter, you don't want uncontrolled ventilation. You don't want uncontrolled leaks creating drafts throughout the house. So what a passive house aims to do is to be able to control that ventilation by making an airtight house, and then providing windows that you can open whenever you like. When you're open, you get fresh air, but also by providing a controlled mechanical ventilation system. And you can see these pipes, which, although they're exposed here in the cellar, throughout the rest of the house are hidden away, are tucked into stud walls and in between floor joists. And this ductwork extracts air from all your kitchens and bathrooms, all your wet rooms they're called, and at the same time inputs the same amount of air into your living rooms, your bedrooms, in general your living areas. Now the extract air, the warm air, is brought down to a centralized Genvex unit down here in the basement and passed through a heat exchanger. And your fresh cold air, which comes in from the outside, also passes through the same heat exchanger. And what that means is that you can recapture all the heat that's in the house and pass that to the air that's going in.
And the beautiful thing about living in a passive house is that you can use all of the rooms and every part of the room all year round. When it's very cold outside, you don't have to hide away from the windows, huddling around the radiators, because the temperature is so even throughout.
So, given the very limited footprint of this house, as an urban building, it's built on quite a small area. What we were very much looking at is trying to get every kilowatt hour of energy that we could from the earth, from the air, from the sun. So we've installed solar thermal panels on the roof. We've installed very high efficiency flat plate panels. Now, because they're very high efficiency and we've provided a lot of water storage, these panels will provide about 60 to 70% of the hot water requirements of the users throughout the year. And that's very much a concept for urban living. What can you get from your patch? So we're in a conservation area here. And what that means is that the windows that you put into the house have to look exactly like the old windows in the house. Now, to be eligible for passive house status, the house has to have very, very low heat loss. And you can't do that, especially on a house with as much glazing as this, without very high specification windows. And so what that means is triple glazed windows with 2 low E coatings, low thermal bridging all around the frame of the window, which is where a lot of windows actually lose their heat. At the time we started this project, that was a product that didn't exist. So as part of the project, we went through a lengthy product design procedure and designed triple glazed sash windows, which are appropriate for conservation areas. These windows don't open in the traditional sliding sash mechanism. The top pane of these windows is fixed, and the lower pane opens in a tilt and turn mechanism, so you can tilt them inwards or turn them to open them fully. That's for a couple of reasons. Firstly, it's impossible to make a sliding sash window completely airtight. Secondly, they would be very heavy, these triple glazed units, to slide up, even with big counterweights. And thirdly, it means that we can use the sash boxes to insulate around the frames of the windows and stop the heat loss through the frames, through the thermal bridges.
Primarily, we wanted to build a very energy efficient house that we could live in for many years to come.
It seemed to make a lot of sense from just building a home point of view as well. You can start from scratch, think about the whole use of the house and how we'd ideally want to live as a family.
We also wanted to pioneer the technology and prove to people that the passive house standard could be achieved in retrofit. And flowing from that, we could show to people that it was possible to take our Victorian homes and create low energy buildings out of them.
I think it's exciting to think that we might be guessing at what future houses will be like, although they might look back and think we got it horribly wrong, like there's films that try and do the future and do it really badly. But yeah, the thought that it might be sort of guessing at how things will be in the future is quite an exciting part of it.
Another reason why we wanted to do this project was because we wanted to show to people who say that low energy buildings have to be ugly that they were wrong, and that it was possible to build a beautiful home which was comfortable to live in and was low energy, where we can bring up our family and live for years to come. So I've never done a big building project before, and every day there was some surprise, almost all of them negative and problematic.
I think it's always a challenge to do a big house like this, especially when the family is expanding during the process, but I think actually it helped us to kind of focus what it was we're trying to achieve as we're going through as well.
There wasn't a huge amount of architectural involvement beyond the initial stage of this project. What it was a very much design and build process.
Unfortunately, when you start taking the plaster off the wall in these old Victorian terraces, you find a lot of nasty surprises. There was a lot of rotting wood, there was a lot of woodworm, there were bowing walls, there were failings in the brickwork, all of which we had to rectify.
And that meant that as we discovered problems, as we went through the build, we could go back to the designs and change things, and it made it a very fluid, very dynamic process. The problem with this house that makes it much more difficult than a typical passive house is its geometry. It's the shape of the house. It generally has all sorts of horrible little angles and tricky parts, and around each of those angles, each of those junctions, you have to do a thermal bridging detail. You have to do a model of that thermal bridging detail to show that you're not losing more heat out there than you thought you were. And you have to make it airtight. And that has meant hours and hours on site with kind of airtightness tape and membranes going around and making sure that each of these junctions is completely sealed, which, although at times is very frustrating, actually makes it a much better learning procedure. Having done 2 houses now to this sort of a standard, I can say that working with the old solid-walled Victorian building stock is going to be difficult, whatever we do.
And I'm sure that a lot of people would prefer not to find out that they have these problems in their homes.
Purely because of the difficulty of working with old houses, and because of the expense involved, and because of the lack of skilled contractors, this sort of level is not going to be the level that every house goes to.
But some of the techniques and ideas we've come up with on this project can be transferred to others. We expect that the final cost will be about 15 to 20% more expensive than a similar home with the same amount of work done to it because of the low energy side of the building.
We've also done a loft extension, a kitchen extension. We've turned the basement into a much more useful, livable space. So the total living area of the house has increased by quite a lot, and hence the value of the house has also increased. I think once you're looking at scaling up this type of retrofit to lots more houses, I think you have to stop before you reach the passive house level. And the level where it is cost effective will vary for different houses, different house types, and also for what you find when you strip away the plaster.
We love the house. The air is incredibly fresh, it's extremely comfortable, and it's just very different from any house I've ever been in.
I've never been in a passive house before, so it was sort of taken on trust that it would feel like it does. I doubted the purity of the air side of things and the heat, and actually it's amazingly snug.
Plus, it's very quiet. The insulation and the triple glazing mean that there's hardly any noise from outside at all. It's just very, very peaceful place to live.
Reaching the passive house standard on these two projects has been an incredible milestone and has been an amazing learning experience for us to try dozens of different techniques and to compare them and to find their cost effectiveness.
So Tom, if you had the chance, would you do it all again?
Yes, absolutely, we'd do it again. And I think if we moved house, we'd do the same thing to our new house. But there are 3 bits of advice I'd give to anyone thinking of doing this sort of project. Firstly, make sure that your plans are all absolutely in place and done before you start the build. Secondly, have a little bit extra in the budget in case you come across these nasty surprises. And thirdly, don't rush it, because although you may feel like you need to get something finished, you'll be pleased that you didn't cut any corners with the end product. Pretty much standard advice for any kind of building project, maybe just a little bit more so in this kind of case because the techniques and the challenges are a little greater.